Hello everyone, welcome back to the physics class of 8th standard. See, my dear students, in the last two sections we have started the sound topic, right? In that we have discussed the basic information of the sound and we have started the next bit of the topic, that is sound is produced by a vibrating body. And in that we have gone through the certain activities like activity 9.1, 9.2, 9.3, 9.4 and 9.5, right? And after this we have discussed about sound produced by humans, and in that we have discussed about the activity 9.6. And then after that we have discussed about sound needs a medium for propagation. And for this we have discussed the activity 9.7, 9.9, 9.8 and 9.9. So till now we have finished the sound topic in the last sections, right? Now we will move towards the next bit of the topic, that is we hear sound through our ears. See, the shape of the outer part of the ear is like a funnel. Okay, so I'll show you the picture of the funnel, how it will be. Okay, so like this only the outer part of the ear will be there like a funnel. When sound enters it, it travels down a canal at the end of which there is a thin stretched membrane. It is called the eardrum. Okay, what it is called? A stretched membrane will be there when the sound travel down a canal. After that canal, what will be there? A stretched membrane will be there, and that stretched membrane is called as eardrum. It performs an important function. Okay, eardrum performs an very important function. To understand what the eardrum does, let us build a thin can model of the eardrum. Okay, so to understand better about eardrum, we have to discuss the activity 9.10. So this activity also you can do at home. So see what we have to do for this activity. Take a plastic or a thin can, cut its ends, stretch a piece of rubber balloon across one end of the can and fasten it with a rubber band. Put 4 or few grains of dry cereal on the stretched rubber. Now ask your friend to speak hooray, hooray from the open end. What will happen after speaking something from the open end? The grains will start jumping up and down. Now here the question arises, why the grains jump up and down? Right? Because of the vibrations. The vibrations are produced because of the pressure created by the sound. Okay, the sound creates the pressure on the rubber. So because of that, what will happen? The grains will start to vibrate. So this is what the way how the eardrum will function in the ear. Okay, so the eardrum is like a stretched rubber sheet. So what is here? The eardrum is like a stretched rubber sheet. Sound vibrates make the eardrum vibrate. Okay, the vibrations of the sound will make the eardrum to vibrate, and these vibrations of the eardrum send to the inner ear. Okay, these vibrations will be sent through the eardrum to the inner ear, and from there the signal goes to the brain. Okay, so what will happen here? First thing, the sound will get inside into the outer part of the ear. From there it will go through the canal. There at the one end of the canal we are having the eardrum. Eardrum is nothing but the thin membrane. It is stretched across the end of the canal. Okay, so when the sound will enters and it will travel through the canal, and when it will touch to the eardrum will create the vibrations, and that vibrations created by the eardrum will send a signal to the brain, and that is how we hear the sound. So this is how we hear the sound through our ear. The next thing we are going to discuss, that is amplitude time period and frequency of a vibration. See, we have learned that the to and fro motion of an object is known as vibration, right? This motion is also called as oscillatory motion. And we have also already learnt in the earlier classes about the oscillatory motion and its time period, right? The number of oscillations per second is called the frequency of oscillation. Okay, the number of oscillations per sound is per second is called the frequency of oscillation. Frequency is expressed in hertz. How we are expressing the frequency? We are expressing it in the hertz. Okay, so it's a symbol is capital H small z. Okay, so this is what the symbol for hertz. A frequency of 1 hertz is 1 oscillation per second. If an object oscillates 20 times in 1 second, so what could be its frequency? Its frequency could be 20 hertz. So, what is the question I have asked you here? If an object oscillates 20 times in 1 second, so what will be the frequency of this object? The frequency will be 20 hertz. So, you can recognize many familiar sounds without seeing the objects producing them. How it is possible, right? We are not seeing that some of the musical instruments, but even though we will come to know that this is the sound of this musical instrument, right? This is the sound of this animal or this bird. How we are come to know that? These sounds must be different to enable you to recognize them. Have you ever thought what factors make them different? So it is different because of the amplitude. Okay, so here we can imagine that many types of birds, animals, many types of musical instruments and different types of peoples also were having the different sound. So how we will come to know that this is the sound is different from that sound, right? This is the musical instrument, this is the bird sound, this is the animal sound. So how we will come to know this all the things? It is possible because of the amplitude of the sound. Amplitude and frequency are two important properties of any sound. Can we differentiate sound on the basis of their amplitudes and frequencies? Yes, we can differentiate it. Okay, we can differentiate it with the help of amplitude and frequency. Okay, so how we can measure the frequency? How we can express it? We can express it in the form of hertz. And the symbol for hertz is capital H and small z. Okay, so this is about amplitude, time period and frequency of a vibration. Now we will move towards the loudness and the pitch. For this we will see the first activity number 9.11. So in this activity we have to take a metallic tumbler and a tablespoon. Strike the tablespoon gently at the brim of the tumbler. How they have shown in the figure number 9.17. Okay. Now hear the sound produced. Now bang the spoon of the tumbler and hear the sound produced again. Is the sound louder when the tumbler is struck hard? Yes, the sound will be louder when the tumbler will be struck harder. Right. Now suspend a small thermocol ball touching the rim of the tumbler as shown in the figure 9.17. Then vibrate the tumbler by striking it. See how far the ball is displaced. The displacement of the ball is a measure of the amplitude of the vibrations of the tumbler. Now strike the tumbler gently and then a little harder. Compare the amplitudes of vibrations of the tumbler in the two cases. Okay. So here what we have to do in the activity? We have to take a tumbler and first we have to take a tablespoon and then we have to strike it on the tumbler. Right. So here we can get the louder sound. Then to the same spoon we have to attach a thermocol at the bottom as shown in the figure 9.17 and then with the help of that thermocol we have to strike it on the tumbler again. So we are getting any sound here louder as compared to the spoon? No, the sound is not louder as compared to the sound produced by the spoon after striking on the tumbler, right? So how we can get this? The sound was louder in the spoon because with the help of the spoon the sound was louder. How we got to know this? Because of the amplitude. Okay, the amplitude will be larger of the spoon sound, because of that the sound was louder. Okay, the amplitude was very small of thermocol sound, so because of that we are getting not much louder sound as compared to the spoon. So the loudness of the sound depends on its amplitude. When the amplitude of vibration is large, the sound produced is loud. When the amplitude is small, the sound produced is feeble. Compare the sound of the baby with that of an adult, right? So this is just an example I am taking for you people. If you compare the sound of a crying baby as compared to the sound of crying adult, so is there any difference? Yes, there is a lot of difference, right? So even if two sounds are equally loud, they differ in some way, right? See, if you are listening a song, okay, see, in a song many types of musical instruments will be played all together, but even though we will easily come to know that this is the sound of this musical instrument. How it is possible? It is possible because of the loudness and the pitch, the amplitude. Amplitude and frequency plays very important role. Because of the amplitude and the frequencies, we will get to know the difference between the sound. See, the frequency determines the shrilling or pitch of a sound. If the frequency of vibration is higher, we say that sound is shrill and has a higher pitch, right? As you can compare here, the boy who is using the drum, right? The sound will be very loud. As if you see the next figure here, the boy is whistling, right? The sound of the whistling will be less louder as compared to the sound of the drum. So if the frequency of vibration is lower, we say that sound has a lower pitch. For example, again I am taking the example of a drum vibrates with a low frequency. Therefore, it produces a low pitch sound. On the other hand, a whistle has a high frequency and therefore produces a sound of higher pitch, right? You can see this, you can observe this in the figure number 9.18. Okay, then here one more example I will take. A bird makes a high pitched sound, whereas a lion makes a low pitched sound. Okay, so however, the roar of a lion is very loud while the sound of the bird is quite feeble. See, every day you hear the voices of children and adults. Do you find any difference in their voices? Yes, we can get the difference very clearly because we have the knowledge of amplitude and frequency. Then can you say that the frequency of the voice of a child is higher than that of an adult? Yes. Why it is so? Because the frequency and the amplitude of a child voice will be higher. Because of that only we are getting the louder sound. Then usually the voice of a woman has a higher frequency than that of a man. So this is what about the loudness and the pitch. Hope you have understood. After this, the next bit is audible and inaudible sounds. See, my dear students, we know that we need a vibrating body for the production of sound, right? So, here I will ask you one question. Can you hear the sound of all vibrating bodies? Yes, the question is what? Can we hear the sound of all vibrating bodies? See, the fact is that sounds of frequencies less than about 20 vibrations per second, that is 20 Hertz, cannot be detected by the human ears. Okay, so the sound which is having the amplitude or frequency of 20 Hertz, okay, or less than 20 Hertz cannot be audible by the human ears. For this we can take the example of ants. Okay, so ants sound we can hear. We are able to hear the ant sound? No, it is not possible with the human ear. So such sounds are called inaudible sounds. Then on the higher side, sounds of frequencies higher than about 20,000 vibrations per second, that is 20 kilohertz, are also not audible to the human ear. For this we can take the example of earthquake. Okay, the sound before earthquake, it will produce the sound, right? So that type of sound also the human ears are not able to hear. So thus for human ear, the range of audible frequency is roughly from 20 to 20,000 hertz. So this is about audible and inaudible sounds. The next thing is noise and music. See, we hear different types of sounds around us, right? So is the sound always pleasing to us? Whether it is a loud or less louder, is it the sound always pleasing to us, right? Does a sound sometimes cause discomfort to you? Some sounds are pleasant to the ear and whereas some are not, right? See, some of the sounds will be pleasant for the listening to the ear and whereas some are not pleasant to the ear. Suppose, for example, construction work is going on in your neighborhood. Okay, are the sounds coming from the construction site that is pleasant for us? No, it is not pleasant for us, right? No. So like that only, do you enjoy the sounds produced by the horns of the buses and trucks? Right? So we can enjoy the sounds of the horns and the buses? No, we cannot enjoy because that type of sound is also not pleasant for the ear. So such unpleasant sounds are called noise. See, like that only one more example. In a classroom, if all the students speak together, what could be the sound produced be called, right? So this is also called as a noise. If you peoples all together will talk in the class, what will happen? It will be discomfort for the all, right? So this type of sound is also called as a noise or unpleasant sound. Then on the other hand, you enjoy sounds from the musical instruments, right? That is musical sound is one which is pleasant to the ear, right? So sound produced by a harmonium is musical sound. The string of a sitar also gives out a musical sound. But if a musical sound becomes too loud, it could remain melodious, right? So this type of sound is called as music or musical sound. Then after this we are having the next bit of the topic, that is noise pollution. You already know about air pollution, then many types of pollutions we are having. Then presence of unwanted gases and particles in air is called air pollution. So similarly, presence of excessive or unwanted sounds in the environment is called noise pollution. Okay, so hope you have understood what is noise pollution. Can you list some sources of noise pollution here? Like blowing of the horns continuously or the louder sounds are played. So this type of sounds will be unpleasant for a ear. Then major causes of noise pollution are sounds of vehicles, explosions including bursting of cracks, machines, loudspeakers, etc. These are the examples for noise pollution. Then here, what sources in the home may lead to noise? What are some sources in the home that may lead to noise? That is television and transistors, radio at high volumes, some kitchen appliances, desert coolers, then air conditioners, all contributes to noise pollution. Okay, so this is just a small bit about noise pollution. Okay, you can put many other examples also. Then what are the harms of noise pollution? How it will affect to the human bodies? Okay, so see, do you know that presence of excessive noise in the surroundings may cause many health related problems, right? Lack of sleep, hypertension, that is high blood pressure, anxiety and many more health disorders may be caused by the noise pollution. Okay, so a person who is exposed to a loud sound continuously may get temporary or even permanent impairment of hearing. Okay, he or she may be not able to hear after some time if he or she will be put or exposed to a loud sound continuously. Okay, so then the next thing is, this is the last bit of the topic, that is measures to limit noise pollution. How we can control the noise pollution? So see my dear students, to control noise we must control the sources of noise. So how can we do that? How we can control the noise pollution? For this, silencing devices must be installed in aircraft engineers. Okay, in aircraft engines we have to put what? Silencing devices. Then transport vehicles, industrial machines and home appliances. So this, by doing this, by using this, we can control the noise pollution. And how can the noise pollution be controlled in the residential areas? How it is possible? How we can control the noise pollution in the residential areas? See, all noisy operations must be conducted away from any residential area. Okay, so how we can control the noise pollution here? Whatever the construction will be going on or any residential area will be there, like outside we have to do that all the things, so that other people should not get disturbed. Okay, now noise producing industries should be set up away from such areas. Okay, the noise producing industries will be set up away from the areas where the other peoples will live. Okay, because that type of industries will produce the sound and that sound will be not pleasant for the human ear, right? And use of automobile horns should be minimized. Okay, whatever the automobiles will be there, okay, so we are putting the horn on that, we are using the horn, so that horn should be minimized, that horn's sound should be minimized. Then TV and music system should be run at low volumes. Okay, at home, how we can reduce the noise pollution? We have to put the low volume music. Okay, we have to put the low volume for the TV or for the radio or any other music system. Then trees must be planted along the roads and around buildings to cut down on the sounds reaching the residents, thus reducing the harmful effects of the noise pollution. So one more thing we can do. What is that? How we can reduce the noise pollution? By planting the plants around the roads and around the buildings. So by doing this, what will happen here? Whatever the sound is coming from the outside, it should not come directly to the human ear. It will get strike with the trees and all. Then by striking, by colliding with the trees and all, what will happen here? The sound will be not that much louder how it was earlier. Okay, so this is what about the noise pollution. So here we will finish off the sound topic. Okay, thank you everyone. Hope you have understood.